naman sa discussion natin for the whole topic ng midterm. So it will be continuation pa rin ng exercises natin. Sorry, may mga naiwan pa palang notes. For a while plus give me 5 more minutes. Okay, class, let's go back. Sorry again. And thank you for waiting. um, Ulitin ko lang, this will be our last discussion before the midterms. And we're almost done naman sa ating module, sa ating topic regarding the fluid machinery, which is pump ngayon. So, ang scope ng midterm natin will be yung discussion natin from the start, from the week 1, fluid properties, flows in pipe, and combination ng ating first fluid machinery na pinag-aralan, which is yung pump. So for today's discussion, as I promised last week, kasi nga napansin ko last week wala tayo or kulang yung discussion natin. Hindi natin naisama yung motor efficiency, motor input, motor rating, or the power consumption kapag nag-ooperate yung pump hanggang fluid proper hanggang brake power lang tayo or fluid power lang tayo. So for today, nag-prepare ako na isang sample regarding that. Meron tayong 2 exercises yung na-miss out natin last week and including yung sinabi ko kanina. Additionally, for this week, since we're done with the analytical and numerical analysis or method in solving the pump performance, mag-introduce mo tayo na tinatawag na pump performance curve. So this is more on graphical methods kung paano natin ma-determine yung performance ng pump. So mas madali na siya, mabilis lang to actually class. It will take us only siguro 1.5 hours overall. So mas madali na dito, using graphical method, using pump performance curve, ma-determine natin later on, once binigay yung capacity ng pump, yung volume flow rate ng pump, we can determine the corresponding total head niya, what is the corresponding efficiency ng pump na yun, ano yung power required para makapag-produce ng ganung capacity at the required total head. At the same time, dito natin makikita yung sinasabi ko even before na yung net positive suction head required is provided ng manufacturer and provided ng designer ng pump. So, let's start. This has been solved previously, kaya na yung last section ko. So, may mga answer na tayo dito. Maganda sana kung face-to-face ulit para sabay natin ma-solve. Pero since wala tayong available rooms and nakaschedule tayo as online, then let's try to solve it or solve it on your own na lang siguro class. Basahin ko muna yung problem. A pump will be installed below the reservoir water surface with a required net positive suction head of 0.0095 miles. So, ang given scenario, given condition is that the pump is installed down below the reservoir. So, tama yung ating schematic. Kung titignan nyo dito sa right side. Yung pump natin is installed below the reservoir. So, the barometric pressure or the atmospheric pressure is 14.3 psi absolute. And the vapor pressure is 0.0005 psi absolute. So, kapag binigyan tayo ng vapor pressure, automatic that will be in absolute pressure. So, assume the friction losses in the intake piping are 1.667 yards. And find the maximum allowable elevation of the pump in feet relative to the water surface intake to avoid cavitation. So, binigay yung key term dito is cavitation. Kapag cavitation, alam natin na related to sa tinatawag natin net positive suction head. Exactly, binigay din sa problem yung net positive suction head required. So, based from the equation of net positive suction head, we need to determine the pressure at suction, the elevation, the vapor pressure, and the friction losses. While it's this muna sa given, net positive suction head required is given 0.0095 miles. Pressure at suction side is 14.3 psi. Binigay na pala siya. Okay, in absolute pressure, wala na tayong kailangang i-add. Then, vapor pressure is 0.0005 psi absolute. While the friction losses, binigay na siya in terms of linear dimension, 1.667 yards. Okay, by the way class, kapag hindi binigay sa problem, ang pressure ng suction side, so don't assume na walang pressure ng suction or zero yung pressure sa suction side unless in-specify na siya is naka-vacuum. So, particularly kapag exposed to sa atmospheric pressure or open reservoir lang siya. So, gauge pressure niya typically is zero. So, if siya is exposed to atmosphere or gauge pressure is 0. Siya ay open reservoir, then absolute pressure sa suction side is just equivalent to gauge pressure plus atmospheric pressure. If the gauge pressure is 0, then atmospheric pressure will be our absolute pressure. So based from the problem dito, barometric pressure very close to 14.7 psi siya, di ba? So equivalent lang siya talaga sa atmospheric pressure. Okay, so let's convert everything. As you can see, the given provided here is not in a standard or in a uniform unit. Medyo masakit sa mata. Miles, PSI, KSI, and yards. So let's make it uniform. English unit yung pinag-uusapan natin dito. And ang kailangan nating output dito is in linear feet. So let's convert everything here from miles to feet, PSI to pounds per feet squared, KSI to pounds per feet squared, and yards into feet. So to convert miles into feet, we know that 1 mile is equivalent to 1.609 kilometer. Then for every 1 kilometer, there is 3,280.84 feet. Or if you want a longer version from kilometer to meters, alam natin conversion, 1,000 lang. Meter, centimeter, centimeter to inches, inches to feet. And it will give you the value of 50.149 feet for the net positive suction head required. While for the pressure at suction side, binigay sa problem is 14.3 psi. So pounds per feet squared, multiply lang natin sa 12 squared or 144. Try nyo guys. It will give you 2,059.2 pounds per feet squared. While KSI, so please remember that just 1 KSI is equivalent to 1,000 PSI. So please remember those conversion class kasi during our exam, during even the board exam, hindi kayo magkakaroon ng references. So everything is stock knowledge. Please memorize those conversion factor. Magagamit yan sa trabaho, magagamit yan during the examination. Okay, so for KSI, multiply it by 1,000 to make it in PSI, and multiply it by 144 or 14 squared to make it pounds per feet squared. For the friction loss, 1.667 yards. Multiply it by 3 feet. So for every 1 yard, there's only 1 feet. Then it will give you 5.001 feet. Okay, now everything is in the uniform or standard unit. Tama ba? Naka-feet tayo, pound per feet squared, feet. Kapag sinubstitute natin yan dito sa equation, makakancel na natin yung mga unit and it will give us the unit of feet later on. So net positive suction head required is equivalent to 50.149 feet. Pressure in suction side is 2,059.2 minus the pressure ng vapor, which is 72 pounds per feet squared, divided by the specific weight ng water. Sa English unit, siya is 62.4 pounds per cubic feet. Okay, so yung elevation na hinahanap kasi natin dito, class, is yung reservoir is above the pump center line. So we know that if it's above the pump center line, yung sign na gagamitin natin dito is positive. So ginamit ko dito is positive. Then ibawas natin ang friction loss, which is 5.001 feet. So one unknown, one equation. You try to solve for your own class. We can get the value of the static suction head, which is 23.303 feet. Okay, then let's try to analyze then the problem. As you know, since we are engineers, ang tanong lagi dito is when we say find the maximum allowable elevation ng pump. So pag binigay mo sa 23.303 feet, is it the maximum na hindi na tayo pwedeng tumaas dyan? Or hindi na tayo pwedeng bumaba sa 23.303 feet? Paano natin madidetermine yan? Again, let's try to solve for net positive suction head available sa system. For a given net positive suction head required class of 50.149 feet, required elevation natin is 23.303 feet. So what if we increase the value here of our net positive suction head, or sorry, the elevation of reserva. Then let us know ano magiging value ng net positive suction head available. Rule of thumb, alam naman natin na NPSHA shall always be greater than NPSHR. So kung ang ating net positive suction head available na makukuha dito is greater than the 50.149 feet, yung net positive suction head required ng ating pump, then the higher nung reserva against, or the higher the reserva with reference to the pump center line, meaning mas preferable siya or mas better siya. Kapag pinaliit naman natin to, then syempre hindi na siya papasok dun sa requirement natin, or it would fit sa requirement natin na NPSHA is greater than NPSHR. So let's try to compute if we replace the value of H sub C with 30 feet. Ang makukuha natin value ng net positive suction head available sa system is 56.845 feet. By comparison, net positive suction head, which is 56.84 feet, is greater than 50.149 feet at elevation of 30 feet. Meaning lang nito is that the higher the reserva above the pump center line, meaning the better yung magiging system natin, ma-avoid natin yung cavitation. So yung binigay na elevation na 23.303 feet, ang ibig sabihin doon, siya yung minimum value, hindi na tayo pwedeng lumapit pa or hindi natin pwedeng ibaba yung reserva o yung pump toward each other. Pwede natin siyang palakihin yung distance kasi mas magiging favorable siya sa design or sa system natin. Okay, class? Let's move. So ito yung problem 13 or example 13. This is a great example actually, class. Kasi it involves, sa problem na to, yung discussion natin last week, on week 1, together with the discussion natin on week 3. So, basahin mo natin yung problem. A centrifugal pump with efficiency down ng 79% is driven by an electric motor having an efficiency of 88%. Lifts water through a total height of 135 feet. So, it lifts water through a total height. Later on, discuss that. From a reservoir to the discharge. Pumping is through 977 feet of 3 inches diameter pipe at the rate of 290 gallons per minute. If the friction factor is equivalent to 0.025 and the electricity cost is equivalent to 3,500 pesos per megawatt hour, find the cost of pumping 1 million gallons. Okay, let's list muna yung mga given. So, binigay sa problem, efficiency ng pump, which is 79%. Motor efficiency, which is 88%. Total height of 135. So, please take note na binigay sa problem is the total height already. So, this is the total static head represented by C sub D minus C sub S, for the difference between the static suction discharge and the static discharge head and static suction head. So hindi natin kailangan mag-prepare ng schematic dito since wala na tayong reference na pagbabasihan. Binigay na sa problem immediately si total height for the elevation head, which is 135 feet. Then length ng pipe, pumping is through 977 feet of 3 inches diameter. So length ng pipe is 977, diameter ng pipe is 3 inches. Volumetric flow rate is 290 gallons per minute. And friction factor is 0.025 and the price ng electricity is 3,500 pesos per megawatt hour. So yung hinahanap dito is the cost of pumping 1 million gallons. So paano yung magiging approach natin dito, class? Okay. So sinahanap sa problem is the cost of pumping 1 million gallons. Binigay sa problem is the cost ng ating electricity. So based from analyzing the problem, or while analyzing the problem based from the given, We know na yung hinahanap dito is yung cost ng electricity, tama? With pumping 1 million gallons. So yung cost associated with pumping 1 million gallons, makanalaman lang natin yan dun sa tinatawag na motor input or yung power consumption ng motor. Directly wala namang consumption na power yung ating pumps. Nakakouple yan sa motor. So yung electrical energy na ginagawa ng motor is transferring it or converting it into rotational energy or mechanical energy na yun ang nagpapaikot sa pump. So basically, yung kukunin natin cost dito is yung motor input or yung motor power input o yung input or electricity na nakoconsume ng motor sa pagpapump or sa pagpapaikot ng ating pump. So, ang approach natin dito is we'll start with the fluid power. We know the fluid power is related to total dynamic head. So once we get the total dynamic head, we can determine the fluid power. Fluid power, we can determine the brake power given in the problem is the efficiency of the pump. Then from the brake power, we can determine the motor power or the input power to the motor since given yung motor efficiency. Then directly, once we know already the power consumption, the motor rating or yung motor power input na tinatawag nga, then we can determine as well the cost of electricity. So to determine the fluid power, we need to multiply the specific weight ng fluid. We know that as well since ang pinapump lang dito is water. Volumetric flow rate, which is 290 gallons per minute, convert lang natin yan later on. Ito cubic feet per second kasi yung mga unit ko natin dito is in English. Then total dynamic head, kailangan natin siyang malaman. So for total dynamic head, it's just a function of difference in elevation from discharge and suction. Binigay siya, which is 135 feet. At the pressure difference naman, check natin. Sa problem, walang binigay. Meaning, walang mini-maintain na pressure or walang required pressure sa discharge side. Ibig sabihin nun, both of them is just a atmospheric pressure. So, kapag sinutrack natin ang pressure na discharge at pressure ng suction, and both of them is atmospheric pressure, then this is just zero value. While for the velocity head or the kinetic energy, wala rin pinigay sa problem na diameter ng discharge side or diameter ng suction flange or discharge flange. Ang binigay lang is diameter ng pipe. So let's assume that both of them is zero. Walang velocity drop or walang kinetic energy drop. And another factor here is what we call the major losses or the friction losses. Okay, binigay sa problem C, friction factor. So let's move to solve the head loss na tinatawag. So gagamit tayo dito ng Darcy-Weisbach equation. Tama ba, class? Binigay sa friction factor. Let me see if kompleto yung ating mga parameters. Length ng pipe, binigay din, 977 feet. Velocity, actually, hindi binigay si velocity, pero binigay si volume flow rate. Binigay ang diameter ng pipe, which is 0.25 feet. 3 inches converted into feet divided by 12, equivalent to 0.25 feet. Acceleration due to gravity is constant, 32.2, and diameter ng pipe is given. So, kailangan natin ma-determine si velocity. So, velocity, ma-determine natin siya by dividing the volumetric flow rate into the area ng ating pipe. So, before that, let's convert muna yung value ng 290 gallons per minute into cubic feet per second para maging standard yung value natin, class. So, directly from 290 gallons per minute, equivalent to 0.646 cubic feet per second. Pero yung conversion factor niya is ito, medyo mahaba lang. Hindi ko alam kung merong shortcut nito. Pero, sige, check natin. For every 1 gallon, there's 3.785 liters. Cancel natin yan. For every 1,000 liters, there's 1 cubic meter. For every 1 cubic meter, 100 cubic centimeter. For every 2.54 cubic centimeter, 1 cubic inches. Every 12 cubic inches, 1 cubic feet. Then, convert natin yung minutes to seconds. 1 minute, 60 seconds lang. will give you 0.646 cubic feet per second. So our friction factor is dimensionless, meaning wala siyang unit. Length natin is nakafit na. Velocity natin, cubic feet per second. Acceleration due to gravity, gagamit tayo dito ng 32.2 feet per second squared, while the diameter ng pipe is 0.25 feet. So, makakancel natin lahat. Cancelable naman yung mga units natin. Let's proceed in determining the major losses. Oh, sorry. Velocity pala, again, sorry, napag-move forward na. Is equivalent to volumetric flow rate divided by area ng pipe natin. Ang area ng pipe natin is pi d squared over 4, wherein the diameter is 0.25. And it will give you 13.16 feet per second. Substitute all those values, class. Friction factor of 0.025. As I said earlier, wala tong unit. Dimensionless siya. Length ng pipe is 977 feet. Velocity is 13.16 feet per second, then raise it to the second power, while the acceleration due to gravity is 32.2 feet per second squared, and the diameter ng pipe is 0.25 feet. So do the calculation, it will give you 262.74 feet. So kinuha lang natin dito, class, yung isang isang parameters consisting the total dynamic head. So zero natin to. So total dynamic head is just a function of elevation and the friction losses. So we know the value already of the difference in elevation, or the total elevation dito, which is 135 feet, as well as the friction losses na nakuha natin earlier, which is 262.74 feet. So i-add lang natin sila parehas, then makukuha natin yung total dynamic head, which is 397.74 feet. Okay. So medyo mahaba yung process natin. Nag-start muna tayo sa pagkuha ng major losses. Then saka natin siya i-add kay total dynamic head. Buti nga lang wala dito si pressure and discharge, si velocity difference. Then substitute the total dynamic head into the equation to determine the fluid power. Specific weight multiplied by volumetric flow rate and multiplied by the total dynamic head. Let's cancel the unit. Specific weight, 62.4 pounds per cubic feet. Volumetric flow rate is 0.646 cubic feet per second. So let's cancel cubic feet here. And multiply by total dynamic head of 397.74 feet. It will give you 16,032.92 pound feet per second. Okay? However, class, ang binigay kasi sa problem, or binigay sa given natin is the cost of electricity at 3,500 pesos per megawatt hour. So given na yung nakuha natin sin pound feet per second or foot pound per second, i-convert natin yan into kilowatt hour muna. Kilowatt. Alam naman natin na both of them are just unit ng power. So megawatt, kilowatt, pound feet per second, horsepower is just unit of power, or unit of energy per rate, or energy rate natin. So let's convert pound feet per second. Ang conversion niya is that for every 550 foot-pound per second, ay meron tayo 1 HP. So for every 1 HP, guys, merong 0.7457 kilowatts. So do the math, do the calculation, it will give you 21.74 kilowatts. Okay? Actually, hindi pa tapos dyan. Kinuha lang natin yung fluid power based dun sa analysis natin nung umpisa. Ang kukunin talaga natin dito is motor power natin. So gagamitin natin yung mga efficiency later on to determine the motor power. So we already have the value of 21.74 kilowatts. So the equation to determine the brake power, kasi dadaan muna tayo. Kunin ulit natin yung pump analysis chart natin. So we already know the value for fluid power. Then, pabalik tayo dito, class. So, from fluid power, kukunin natin si brake power gamit yung efficiency ng pump. Then, from brake power, kukunin natin si motor power gamit yung motor efficiency. Okay, so ang equation natin to determine the brake power is efficiency ng pump is equivalent to fluid power divided by brake power. We know the value of the efficiency ng pump, which is 79%. We know the value of the fluid power, which is 21.74 kilowatts. Then you can get the value of the brake power by dividing 21.74 kilowatts to efficiency of the pump, which is 0.79%. Technically, it will give you 27.516 kilowatts. So para hindi tayo malito, class, efficiency, please remember that energy out divided by energy in. So based from sa analysis natin, pump analysis. So everything on the left side, for example, ang kinukuha natin fluid power, the brake power is the energy in, while the fluid power is the energy out. Kapag naman sa motor side yung kinukuha natin, then at the left side is motor power, then that is the energy in, while the right side is the energy out, which is the brake power. Since we know already the brake power, we can determine the motor power using the efficiency ng motor. So the equation is brake power divided by motor power is equivalent to motor efficiency. And pagkuha ng motor power is dividing the brake power lang sa motor efficiency, which is 88%. So it will give you 31.27 kilowatts. Okay, class? There's an easy way pala to do this. Hindi na tayo tadaan sa dalawang equation na to. Last week, we introduced yung tinatawag na overall pump efficiency or overall efficiency. So we know that the overall efficiency is just the product of the pump efficiency and the motor efficiency. So by comparison dito kanina, from motor power directly to fluid power, ito yung tinatawag na overall pump efficiency. Meaning, ang formula natin dito is fluid power divided by the motor power. Ang output natin dito, as usual, laging fluid power, while the input here is the motor input or yung motor power natin. So, i-divide lang natin si fluid power sa overall pump efficiency, which is the product of the pump efficiency and motor efficiency. Makukuha na natin yung motor power directly. So, do the math, class. Parehas sila na magiging sagot lang. 31.27 kilowatts. Okay? So, kapag hindi binigay sa problem si pump efficiency at si motor efficiency, while binigay sa problem si overall efficiency, then we can use that to determine the motor power kapag kinuha natin si fluid power initially. Okay, then let's move on. Since ang hinaharap talaga sa problem is the cost of pumping 1 million gallons, then we need to determine muna how many hours is required para makapag-pump tayo ng 1 million gallons if our capacity is 290 gallons per minute. So let's divide 1 million gallons by 290 gallons per minute. Makukuha natin yung number of minutes na kailangan makakapag-pump yung or makakapag-deliver yung pump natin. Since 1 million gallons divided by 290, it will give us a unit of minute lang naman. And once we know already ilang minuto or ilang oras ang pump na tumatakbo, i-multiply lang natin yun sa motor power na nakuha natin. At the same time, multiply natin siya sa cost of electricity para makuha natin yung presyo remaining or yung total cost ng electricity total cost ng pumping 1 million gallons kapag ang cost ng electricity is 3,500 pesos per megawatt hour. Okay, so as I said, let's divide 1 million gallons into the capacity of our pump, which is 290 gallons per minute. Then, let's convert those minute, kasi makuha natin dito is in minute, to the hour. Then multiply that by the motor power, which is 31.27 kilowatts. Since yung cost ng electricity natin is in peso per megawatt hour, convert muna natin yung kilowatts into megawatt hour. We know that for every 1,000 kilowatt, there is 1 megawatt. So, cancel this one, cancel this, power, and multiply it by the cost of electricity in 3,500 pesos, will give you 6,290 pesos. So it will take 6,290 pesos to pump 1 million gallons of water kapag ang cost ng electricity natin is 3,500 pesos per megawatt hour, and yung capacity ng ating pump is running 290 gallons per minute. So basically, it will took around 57 hours para makapag-pump tayo ng 1 million gallons kung ang capacity ng ating pump is 290 gallons per minute. And for that 57 hours, actually multiply mo lang din siya sa kilowatt para malaman natin kung ano yung consumption ng ating motor when it comes to kilowatt hour. Okay class, let's move to the next problem. Okay. So tapos na pala tayo dito. Basically hanggang example 13 lang yung na-prepare natin for this module. We have another example 14 but is related naman to kung paano binabasa si pump curves or ating pump performance curve. So we did already around 13 example problems since last week. This related to lahat sa mga pumps. So sana naintindihan natin yon. Medyo madami-dami naman yon. We discussed from the start centrifugal pumps, positive displacement pumps, net positive suction head, specific speed, affinity loss, na nakapagbigay naman tayo ng lahat ng example. So pump analysis, nakapagbigay rin tayo dito ng example from the major losses or friction losses. Kinuha natin siya para makuha si total dynamic head. Then from total dynamic head, determine natin yung fluid power. Then fluid power, directly kaya natin makuha si motor power using the overall efficiency. And once na nakuha natin yung motor rating or yung motor input, motor power input, or yung cost of makukuha na natin yung cost of electricity. Okay? Okay, so let's move. Tinatawag na graphical method naman to determine the pump performance is using the pump performance curve. Hopefully makita nyo ng maayos. Medyo maraming details na binibigay dito class. Isa-isahin natin yan para mas madali nating maintindihan. So we'll start first with kung ano yung nasa y-axis natin on the left side. Basta naman siya, total head in meters ang nakalagay, while the other one is total head in feet. So kung reference natin is metric unit, then gagamit lang tayo ng meters. Kapag English unit, then gagamit lang tayo ng feet. On the axis naman, on the x-axis, ang makikita natin dito is from 0 to 250. The capacity stated here is the volumetric flow rate or the flow rate ng ating pump. Then from 0 to 1,200, that is the capacity in gallons per minute. So both of them are in volumetric flow rate. Mag-iba nga lang din siya kung English unit or metric unit yung ating reference. While on the y-axis on the right side naman class, okay, makikita natin dito si net positive suction head in feet and net positive suction head in meters. So Ayun, net positive suction head required, madidetermine natin or mapoprovide siya ni manufacturer or the designer. And highlight ko lang in yellow yung curve na to. So kung makikita niyo yung naka-highlight na yellow class, ito yung curve ng net positive suction head required. Paano siya basahin? For example lang, at 800, or sorry, ito na lang, at 900 gallons per minute. Then i-project natin to x-axis. So kung saan mag-intersect yung ating net positive suction head required na curve dun sa capacity ng ating pump, which is the volumetric flow rate. Then i-project mo siya to the right axis, to the y-axis on the right. Then madidetermine na natin yung net positive suction head required ng pump. So kapag ang given na yung pump natin dito is 1,750 RPM, so once yung pump natin nasa 1,750 RPM, project natin yung capacity ng pump, which is 900 gallons per minute. Makukuha natin yung net positive suction head required as around 21 feet or almost 6.4 meters. So example lang to class, kung saan mag-intersect yung ating capacity ng pump dun sa net positive suction head required curve. Project mo to the right, makikita natin or ma-determine na natin yung net positive suction head value. Okay? So, matatanong natin or mapapansin natin, so si net positive suction head required pala is dependent lang sa capacity ng pump. Meaning, mag-iiba or magbabago yung value ng net positive suction head required depending on the capacity ng ating pump or sa volume flow rate na napoproduce. Which is totoo. I think this is gradually increasing, or the higher the capacity or the volume flow rate, the higher will be the net positive suction head required. So directly proportional pala siya. Okay? Then let's move to the other part of the graph. I'll just highlight it into different color para hindi tayo malito. So, okay. On the left side, makikita natin yung value as 7 1/4 inches, then gradually increasing up to 9.5 inches. So, ito class ay ang tinatawag na diameter ng impeller. So, si manufacturer pala, even though rated yung pump natin at 1,750 RPM, binigyan tayo ng flexibility na mapalitan or makapag-swap, mag-replace ng iba't ibang klase ng diameter of impeller. So, pwede siyang mas malaki kasi may limitation lang kung anong given lang dito sa chart. So, from 7 1/4 and to 9.5 inches in diameter. So, for this example, gamit lang tayo ng 9 inches. I-highlight ko siya sa blue. Okay. Then, another numbers na mapapansin natin dito is yung mga nasa taas. So, from 50% going to 60%, 65, 70, 75, 80, so on and so forth. Hanggang sa ba siya yung pinaka-peak, which is 83.5%. Then, pababa na ulit yung value from 83, 82, 80, 75, and 70%. So, those guys, alam naman natin na kapag naka-percentage, siya yung efficiency ng pump. So, as much as possible, let's try not to operate a pump beyond those data here class. So, as much as possible, let's maintain the pump performance within the middle lang, around 80%. So, kapag yung pump natin nagpe-perform or nag-ooperate beyond those charts, then technically, definitely may hindi magandang mangyayari. It may cause damage or losses. It comes to cost. And lastly, mapapansin natin dito yung value in HP. So, from 7 1/2, 10 HP, 15 HP, and 20 HP, These are the power required para makapag-operate yung pump natin at a desired capacity at the same time makapag-produce ng required head. So let's try to mix and match those values. So example, using 9 inches diameter ng ating impeller, ang ating pump is running at 1,750 RPM. Highlight ko lang, 1,750 RPM. And gumagamit tayo ng 9 inches in diameter. Naka-highlight na siya sa blue, yung 9 inches glass. Then our pump is running at, let me say, 800. Or better, at 700. Okay. Let's make it as red para madaling ma-identify. Okay. Then project lang natin the right side. Madidetermine na natin yung output ng ating pump in terms of the total head. So let's write it first para mas madaling maintindihan. So given that our pump is running at 1,750 RPM, so our speed is 1,750. The capacity, sample lang na to, capacity na kinuha natin is 700 gallons per minute. Diameter ng pump while operating is 9 inches. Yung project natin into y-axis, nakuha natin na kaya pa niya mag-produce ng around 62 or assume lang 64 or 63 total head in feet. Sorry. Then, yung required power natin for the pump to operate on this condition, as you can see, the point of intersection is in between 10 HP and 15 HP. So, kukunin natin dito is always the higher. So, power is 15 HP. So, we need 15 HP for the pump to operate in this condition to supply 700 gallons per minute at the same time, makapag-produce ng 63 feet of head. Then pump efficiency is in between 83%. And dito tayo sa curve na to. So efficiency natin is 83%. Actually, hindi pa tayo tapos class. We can still determine the net positive suction head required based from the graph. So kung saan nag-meet yung ating capacity against, or kung saan nag-intersect yung capacity against the net positive suction head required na curve, madidetermine natin ang required net positive suction head. So, based from the graph, NPSH is equivalent to, dito sila nag-intersect, so let's assume around 9 feet. Tama ba, class? Clear ba sa atin? So, ano lang naman to, kung ano yung inanalyze natin last week and last week, even the first part ng ating discussion for today, using numerical method, analytical method, this is more on a graphical method naman. Paano natin ma-determine yung performance ng ating pump gamit yung pump curves or pump chart. So, based from this, siguro dito magre-reflect yung tinatawag na a picture is worth 1,000 words, tama? Kasi based from this curve, ma-determine natin using using the capacity, yung operating capacity ng pump. Ma-determine natin yung total head na mapuproduce, power required para makapag-operate sa ganung capacity, efficiency ng pump, net positive suction head required. So, medyo usable or maganda itong gamitin during the operation or designing yung ating system. By the way, class, itong pump performance curve, binibigay ito ng suppliers kapag bubili tayo ng pump. So, magagamit nyo to or kung hindi ito binigay, pwede nyo i-request yan. Laging meron yan si supplier. Siguro magagamit ito definitely sa design, pag nasa design kayo. Pero kung wala kayo sa design at nasa maintenance tayo or nasa operation and something na kailangan natin i-improve yung system, then definitely pwede natin i-refer yung pump performance curve. If we want to change the impeller, anong next na magiging changes niya or improvement niya, what will be the new total head at the same capacity kapag pinalta natin sa impeller. Okay? So, example 14.0. Last example natin, this is to ano lang naman, to provide a more clearer view dun sa pump chart natin or pump performance curve. So, let's try to solve it in terms of exercises. Determine the elevation. Let's close this. Okay. Para hindi lang naman determine the elevation of a 9-inch diameter pump that can be situated above the water surface of the suction reservoir without experiencing cavitation. The water temperature is 60 degrees Fahrenheit and the volume flow rate is 200 cubic meter per hour. Neglect losses in the pipe. So medyo limited yung given sa problem. Pero let's try to draw it first para mas madali natin maintindihan. So sinasabi natin or sinasabi sa problem na hanapin daw yung elevation ng 9 inches diameter na pump that can be situated above the water surface of the suction reservoir. Unlike sa una nating example, yung pump natin, yung nasa baba ng water reservoir, tama. Yung reservoir, yung nasa taas ng pump. So based from this, and we determined also based from solving this problem, na kapag yung reservoir natin is nasa taas ng ating pump, the higher the elevation ng ating reservoir, or the greater the difference, or the greater the length, or the distance between the two of them, then mas favorable siya sa system. Tama? Kasi nakarelate siya sa net positive suction head available sa system. So, the greater the difference between the two of them, or the greater the distance, the greater the value na makukuha natin sa net positive suction head available, which is greater than the net positive suction head required. Pero there's always a limit kasi once na itiraas natin siya, meaning mas maraming cost ang makakonsume natin sa raw material pa lang, sa pagbili pa lang ng ating pipe. So lahat naman yun, i-consider nyo sa pag-design. Hindi lang, lang to, kasi nga fluid machinery lang pa nag-uusapan natin o hindi determine natin. Then more on properties lang or ano yung input lang natin na required sa fluid machinery, which is yung pump. While for this problem naman, yung pump natin yung nasa taas ng ating reservoir o yung reservoir natin yung situated below dun sa pump. So tama yung ating schematic. Next natin kukunin is yung mga given. So binigay sa problem, diameter lang ng pump, water temperature, at the same time yung volumetric flow rate. So again, without experiencing cavitation, related na naman sa cavitation, so ang equation natin dito will be the net positive suction head required is equivalent to pressure ng suction minus vapor pressure minus the elevation, which is ito yung kukunin natin, minus the friction losses. So sa friction losses, pinapaneglect sa atin, so 0 lang. Kailan natin ma-determine para makuha si elevation is the net positive suction head required, pressure ng suction, and the vapor pressure. gusto natin kukunin si net positive suction head required. So ito yung na-verify natin kayo na sa graph. It's a function only ng volume flow rate. So since volume flow rate is 200 cubic meter per hour, check lang natin si 200 cubic meter per hour. So we'll use the bottom details kasi naka-metric unit tayo. Then kung saan mag-intersect yung ating capacity and sa ating NPSH chart, then yung nakukunin natin net positive suction head required. So sa kanan, lumabas na yung ating NPSHR is in 6 meters. So check lang natin si 200 cubic meter per hour, nag-intersect sa NPSH chart, then na-determine natin yung net positive suction head required in meters, which is 6 meters. Okay, then sa natin kukunin naman si pressure ng vapor. So okay na si net positive suction head required. May value na tayo dito. So vapor pressure naman, please remember that vapor pressure is relative or dependent sa ating temperature. So may corresponding pressure depende sa kung ano ang binigay na temperature. So you can search the internet. Actually, nakikita nyo sa internet yan. Pero nasa module din natin. I think this was discussed on week 3. If the vapor temperature dito na binigay is, or the water temperature here is 60 degree Fahrenheit. At 60 degree Fahrenheit, there's a corresponding or equivalent value of the vapor pressure, which is 0.256 PSI. So class, kapag binigay si vapor pressure, lagi siya naka-absolute value na. So, vapor pressure here is 0.256 PSI. Okay? Next, since meron na tayong vapor pressure, sunod natin kukunin is the pressure ng suction side. Okay, so pressure ng suction side, sabi ko nga, kailangan natin kunin is absolute pressure. So, pressure ng suction side is gauge pressure plus the atmospheric pressure. So gauge pressure here class is 0 kasi wala namang binigay na gauge pressure dito. So atmospheric pressure natin dito is equivalent to the absolute pressure. So kapag gauge pressure is 0, then absolute pressure natin is the absolute or atmospheric pressure. So in metric unit, ang ating absolute pressure or atmospheric pressure is 101.325 kPa. So kompleto na tayo ng values, kompleto na tayo ng data. One equation, one unknown, makukumpleto natin yung value ng elevation ng ating reservoir below the pump. So just calculate guys, do the math, makakalculate nyo naman. Then we can determine the elevation, which is 4.14 meters. Okay, so again, let's analyze the problem. Is the 4.14 meters the maximum na pwede nating, siya na yung maximum ba? Meaning hindi na siya pwedeng bumaba o hindi na ba siya pwedeng itaas sa 4.14 meters? Paano siya malalaman? Let's try to calculate the net positive suction head available. So for a given net positive suction head required of 6 meters, ang nakalculate natin na elevation must be 4.14 meters. Then what if, let's try to reduce the value of 4.14 meters into 2 meters. Ang makukuha natin net positive suction head available dito class is 8.1493. Meaning, it is still greater than the net positive suction head required. So, ano ibig sabihin nun? Ibig sabihin nun, pwede pa pala nating palapitin or make it closer yung pump natin against or towards si reserva. However, kapag sinubukan natin palayuin pa yan, for example, increase the head or increase the elevation by at least 8 meters or 6 meters, then mapapansin natin na liliit na yung ating net positive suction head available. Mas liliit na siya sa ating required net positive suction head, which will cause cavitation. At ito nga iniiwasan natin, class. So yung maximum na hinahanap dito, maximum elevation or determine the elevation, meaning siya yung maximum na pwedeng ilagay natin yung pump, pero pwede pa siyang palapitin pa. Pero hindi na siya pwedeng mas malayo pa. Understand, class?